what we're going to do is for each of these, we're going to answer the question that they ask, but we are also going to draw the graph. So if you had to graph y equals 2/3 sine x with that vertical compression, what would it look like? Okay. So first of all, you would have your parent graph of sine x off to the side, or in your head, right? It goes as the axis family labeled, as a maximum of 1 and a minimum of -1. Then when I go to graph the blue graph, does it make sense that the only thing that we have here is a vertical compression? It's only going to change our y values. So I'm still going to put my axis family 2 pi, pi, pi over 2, and 3 pi over 2. And can you see wherever the y values are 0, they would stay 0. But instead of having a value of 1, when you multiply your y value by 2/3, can you see that you would get 2/3 instead of 1? So it changes your maximum value to 2/3 and your minimum value to -2/3. And our amplitude becomes 2/3. So right now, we're looking at a vertical stretch which has the A value, and we notice that if your A value changes, your amplitude changes. Now you're going to have to come up with something really strategic to remember that the A value changes your amplitude. I don't know how you're going to remember that your A value changes your amplitude. You'll have to come up with something really, really smart and strategic for that. But this will be our first shortcut. That instead of doing a vertical compression, we'll be able to say right away, oh, I know my amplitude is 2/3. If I draw my axis family and now make my amplitude 2/3, which changes my maximum value and my minimum value, I can draw the shape quickly, instead of changing all 5 points and writing that all up. Same thing's going to happen for B. Oh, but B also has a reflection. We're going to talk about that as well. So in B, we have y equals -4 cos of x. We would think about our regular cos graph with our axes family. So I label all my axes. Maximum of 1, minimum of -1. My cos graph starts at the maximum, center line, then minimum, then center line, then maximum. Here's my regular cos graph. Maybe I should have. It's not going to be quite to scale. Can you see that this, again, is a vertical reflection and a vertical stretch? So everywhere on my axis family, everywhere where we had 0, it's still going to be 0. So those 2 points would still be at 0. But my maximum at 1 is now going to be a minimum at -4. And my minimum at -1 is now going to be a maximum at 4. So if I took this y value and I multiplied it by -4, it would go down to here. And this one would go up to here, and this one would go back down to here. And here is our final graph. The amplitude, and we'll draw that line in here. Is 4. So our A value is -4, but the amplitude is always a positive number because it's a distance. So even though there's a -4 out in front, our amplitude is still 4. But we also had that vertical reflection. So one of the things that you're going to hear me talk about is that when I talk about a cosine graphs normally start at a maximum because the starting point on your regular cos graph is at a maximum. A negative cos graph then starts at a minimum. A sine graph, you'll hear me talk about starting in the middle, going up. And it's important that I say middle and not 0, because sometimes your middle won't be at 0. So it's going to start in the middle, going up. Does it make sense that a negative sine graph would start in the middle, going down? So that reflection, that vertical reflection for cos, changes it from starting at a maximum to starting at a minimum. For sine, changes it from starting in the middle going up to a middle going down. So we take the negatives, but the negative doesn't affect the amplitude. Whatever your A value is still going to be your amplitude. Questions you can do for practice are 3, 8, and B you can circle, as well as 4, 5, and 9.